It just dawned on me in this 10th and final video for homework 11 polynomial functions that I've had my baseball cap on the entire time. Yeah, well. Alright, so the last video is we're going to call recovering a function from its graph. For example, here's a sketch of a graph. I just made it up. And we're going to find a polynomial of minimal degree whose graph does this. That's a pretty weak verb there, does this, but we'll just go with that. Well, how can we figure out what the function was? Well, the trick to recovering a function from a graph is to look at two places, or at least two places, the end behavior and the X intercepts. Let's start with the end behavior. The left rises and the right falls. We could go to our table and see what that means about the leading coefficient and the degree, or we could reverse engineer the gimmick. Because the right falls, this means that the leading coefficient is negative, and because the ends are opposite ends means that we have an odd degree. So at the end, I need a negative leading coefficient and an odd degree. Okay? But what about the X intercepts? How could we reverse engineer those? To reverse engineer an X intercept, start by saying X equals. In this case, X equals 3. But remember how we found X intercepts. We put factors equal to 0 and solved them. To reverse engineer this, we have to put it back to 0 by moving the 3 over. What that means is that X minus 3 is a factor. But is that all we know? Nope. This touches and turns. And what does that mean about the multiplicity? Touch and turn means that you have an even multiplicity. And remember, multiplicity is just the power on the factor. So we need to put an even power on this factor. Which even power? 2, 4, 92? Well, since we want minimal degree, we want to keep the powers as small as possible. So we need a factor of X minus 3 with the smallest possible even power. We'll say 2. Now let's reverse engineer this other X intercept. The other X intercept is X equals 7. That means it came from the equation X minus 7 equals 0. That means that X minus 7 is a factor. Let's try that again. Is a factor. But what about its power? This crosses. That means odd multiplicity. So we want an odd power and keep it as minimal as possible. So the smallest odd power we can use is 1. So let's glue it all together. Therefore, f of x is equal to x minus 3 squared and x minus 7 to the first. So I don't need to write the first power. Does this capture everything? It definitely captures the intercepts. We worked hard on those. But there's one other thing that we haven't checked yet. And it was the first thing we talked about. The end behavior. Does this function have an odd degree? Yes. If I were to write out this parentheses twice and grabbed all the leading terms, it would be x times x times x, which is x to the third, which is odd. But what it fails to have is a negative leading coefficient. So how can we make the leading coefficient negative? And the answer is put a negative number in front. Now in the homework when they do this, they say either use 1 or negative 1. Basically what they're saying is if you need to make sure that the leading coefficient is negative and it's not, stick a negative 1 on it. And that function does everything that we want it to do. For those of you who are really paying attention to videos and doing your due diligence, I'm about to give